In this video, I will explain on the starch hydrolysates or known as sweeteners. So starch can be hydrolyzed using its acid or enzyme or by a combination of acid and enzyme treatment. So there are large variety of products that can be obtained from starch hydrolysis, including various starches such as cornstarch, wheat starch, potato, and also cassava or tapioca starch. So this is a diagram of cassava starch and cornstarch and potato starch. Although they look similar, but of course there are different. There are some small detail difference between these starches. Okay. Um, so glucose syrup, they are hydrolysis product of starch with varying amounts of glucose, monomer, dimer, oligosaccharide, and also polysaccharide. So this degree of hydrolysis is expressed as dextrose equivalent, which is defined as the amount of reducing sugar present as dextrose and calculated as a percentage of the total dry matter, meaning dry weight percentage. Dry weight percentage. Okay, dextrose equivalent, DE. So this value varies in different types of glucose syrups. So glucose syrups can have a DE greater than 20 and also less than 80. So DE that is less than 20, the products are referred to as maltodextrin, while DE more than 80, so the products are normally referred as hydrolysates. And the properties of the maltodextrin are influenced by the nature of the starch used, and while those of hydrolysates, they are not affected by the type of starch. So this depends on the starch, but this one is independent. Does not depend on the type of the starch used. Okay, in starch hydrolysis, the initial step involve the use of heat-stable alpha amylase. This alpha amylase enzyme, it randomly attack alpha-1 for glycosidic bond, which reduce in rapid decrease in viscosity. So this enzyme can be used at temperature as high as 105 degrees Celsius. And this reaction will produce maltodextrin, which can be used as fillers, stabilizer, and thickeners in food products. Okay, so the next step is the saccharification by using a series of enzymes that hydrolyze either alpha-1,4 linkage of amylose or alpha-1,6 linkage of the branch amylopectin. So the action of the various starch degrading enzyme is shown in the next figure. Okay, this is the amylose. Okay, the amylose, and this is the alpha-1,4 link. And if you see amylopectin, this is the alpha-1,6 link. Okay, so A here is amylose and amylopectin. So if you look at the B, B refers to action of alpha amylase on amylose and amylopectin. You see, this alpha-1,4 link is now destroyed, and in this case, this is retained, but this one is lost. Okay, and C here, action of the branching enzyme on amylose and amylopectin. So it eliminates the branch. That's why it is called debranching. You see, it used to be branch like this. Now it is debranching. And then the action of amyloglucosidase here. and debranching enzyme on amylose and amylopectin. So it destroy the link, 1,4 link, 1,6 link, and also cause debranching. So become like a single unit. Okay. In addition to products containing high level of glucose, sweeteners with DE as follow can also be produced. For example, maltose having DE between 40 to 45, high maltose having DE from 50 to 55, while high conversion syrup will have DE value of 55 to 70. And high dextrose syrup can be obtained by saccharification with amyloglucosidase. So starch hydrolysis, the next step is the isomerization of glucose to fructose. So this process is done using the enzyme glucose isomerase in enzyme reactors, and the conversion is reversible and the equilibrium is at 50% conversion. So when you use glucose isomerase, so you can convert glucose to fructose in 50% conversion. And this high fructose syrup are produced with 42 or 55% fructose. Okay. So this is the schematic diagram on the step involved in starch hydrolysis. So you have the starch slurry, it undergo liquefaction with alpha amylase to give you a maltodextrin. So once this slurry undergo liquefaction, if it undergo a subsequent reaction, which is the saccharification, using debranching enzyme, which is glucoamylase and glucuronase. So it will give you a debranch compound, yeah. And then after some purification, it will give you either maltose syrup, glucose syrup, or mixed syrup. And this product, after purification, when it undergo isomerization, and using glucose or isomerase, it will be converted into fructose. Yeah, fructose. Remember isomerization, when you have isomerase, it will give isomerization, and when it refine, it give you a fructose syrup. Okay, another important compound of a carbohydrate derivative is polyols or sugar alcohol. So it occurs in nature and they are produced industrially from the corresponding saccharide through catalytic hydrogenation. So the most widely distributed natural polyol or sorbitol is found in many fruits such as plums, berries, cherries, apples, and pears, and it is a component of fruit juices, fruit wines, and other fruit products. And this sorbitol can be commercially produced by catalytic hydrogenation of D-glucose. So you have D-glucose, and then you undergo catalytic hydrogenation and it will give you sorbitol. Sorbitol is common in food products. If if you look at candy, ingredients in candy, you will normally saw the sorbitol, and also chewing gums and all that. Okay, so how does a starch being converted to sorbitol? You have a starch, it undergo enzymatic hydrolysis, it will give dextrose syrup and maltose syrup. And this dextrose and maltose, you undergo hydrogenation, it will give you sorbitol syrup. And this sorbitol syrup, it undergo crystallization, will give you sorbitol. Okay, you remember crystallization, what happened when you have sorbitol syrup? You turn it into a supersaturated solution and then it will give you a sorbitol crystal. Okay, that's the end of this video and thank you for listening.